Okay, here's the ideal gas law. PV equals nRT. All right, so when you're dealing with a problem that's the ideal gas law, you've got to know a couple of things. First of all, there's this wonderful little thing called R, which is the ideal gas constant. You have to use a constant that is in accordance with the units of pressure. Okay, very important. So let's read the problem and I'll show you what we're talking about. It says, what is the volume of the gas that is occupied by 7 moles of oxygen at 28 degrees Celsius and a pressure of 2 atmospheres? You see, right here we know the pressure, and the pressure is in atmospheres. So we have to make sure that we use a gas constant that is also in atmospheres. Now, your teacher may or may not require you to remember this, okay? But it should be 0.0821, okay, liter atmospheres per mole Kelvin, okay? Now I know those are funky units, but those are built off of all of the individual pieces of the ideal gas law, right? P is for pressure, V is for volume, N is the number of moles, all right, so that's easy. We're going to put that one right in there. The temperature must be in Kelvin, okay? So I'm going to write that, must be in Kelvin. Now, hopefully by now, if you're up to the ideal gas law, you probably already know how to convert Celsius into Kelvin, but let's recap. You take the Celsius temperature, you add 273, and then that gives you the temperature in Kelvin. So this 28 degrees that you see here, you can take 28 plus 273, and then let's do that on the calculator. We come up with 301 Kelvin, okay? So that's the number that we're going to need to use in place of temperature, all right? So this is our temperature. All right, so it looks like the only thing that we don't know is the volume. So I'm going to write the ideal gas law one more time. And it's important that as you practice these problems, you also write the equation before you proceed, because then you're learning the equation without having to sit there and write it a million times. Okay, that's really boring. And it's more effective if you solve lots of chemistry problems and you write the equation down every single time. That way, by the time the quiz or the test comes, you'll already know it. It will become automatic. All right, so the pressure is in atmospheres. So we're going to put in 2.0 atmospheres of pressure. The volume is in liters. And, oh, wait a minute. That's what we're looking for. We're looking for the volume because it says what volume. So we don't know the volume yet. All right, the moles, which is represented by N, is 7. The gas constant is 0.0821. And the temperature is 301. Okay, so the only thing that we need to solve for is this volume. So I'm going to divide both sides by 2, and then we can solve for V. Okay, so 2 goes bye-bye, bye-bye 2, and then we're going to multiply 7 times 0.0821 times 301 and divide by 2, leaving our final volume at 86.49. Now you may wonder, is this milliliters? Is this liters? You know, what is it? Well, if you remember, in the gas constant, the volume is typically written in liters. Okay, that's the typical unit for ideal gas law problems. Okay, so I recommend that you always use liters in your problem solving. So if you solve for a volume, your answer comes out to be liters. Okay, proving it with the units, we can do that cancellation, but trust me when I say that this is the right way to go. Okay, so that's how you solve an ideal gas law problem. And if you need more practice, watch another video, and I'll see you next time.